And again, continuing our discussion on tools and techniques related to asset management, we will be discussing a particular, you can say, methodology, which is referred to as Taguchi methodology or Taguchi methods. So, this particular method or the methodology, I will be discussing the next 1 hour or so, and in the next session there will be one tutorial, and this tutorial will have 2 parts. The first part Professor Mohanty will be dealing with, and the second part for about 40 to 45 minutes I will be giving you a tutorial on Taguchi method. Now, how many of you have heard his name? Genichi Taguchi. Japanese name. He is a Japanese and well known, not only in the circle of universities, but also in industries. Here is one person who has developed his technique, method, whatever you say, staying on the shop floor. So what will you find that the widest possible application of Taguchi method you will find in industries. You name any world-renowned organizations or industries, definitely, directly or indirectly, they have been using Taguchi method. And obviously, when some method is accepted in industries, obviously we may conclude that industries are getting some tangible benefits. Okay. So this is the background, and as I have already told you that Taguchi is a self-made person. He didn't have the university degree. So the basic concept is absolutely, well accepted. But what happens in some cases when he proposes some, statistical techniques, some of these statistical techniques are questionable. Okay. So this has been pointed out, and he admits that. And there are other persons who actually worked on Taguchi method, and they are very well-known researchers. They have perfected his statistical technique. Getting my point? Like many of you may be knowing about analysis of variance. You may be knowing ANOVA table. Taguchi, doesn't use ANOVA. He uses ANOVA, analysis of means. Okay. So these are and there are some assumptions you have, linearity assumptions and all those. So keeping aside those aspects, there are many issues which he deals with. They are very, very relevant. Now, 3 important aspects are related to Taguchi. You must be aware. First one is there is a term called quality engineering. This particular term was coined by Taguchi. You know what is engineering? What is engineering? What is the meaning of engineering? 1 word or 2 words. What is the meaning of engineering?
To devise something.
No, but if the sentence with one finite verb and all this. Just a few words I want, and you hit the point. This is engineering per se. What is engineering?
Application.
Have you seen the meaning of the engineering in the dictionary? Webster or Oxford and all this. Right. So there it is very clearly mentioned. The engineering means design, essentially. Design of a product, or design of a system. It deals with designing. So so an engineer is a designer. So obviously when I use the term called quality engineering, he uses the term quality engineering. It means quality is to be designed. Where? Into the product. Is it okay? So the quality normally, what happens? You ask any of your, superiors. Traditionally, the superior may have a knowledge. Like, you say, what is quality? Say, we are involved in design. So the design determines the quality. That's the traditional approach, Western approach, initially. 19th century, 20th century, okay, almost, the first half of the 20th century. Then, during 50s, what happened that Taguchi brought his concept when he was working here in Indian Statistical Institute, Calcutta, mid-50s. And he used to be frequented by our first Prime Minister, Nehru, and Maulana Bish. So, if you visit ISI, you'll find that there are photographs. Nehru, Maulana Bish, and Taguchi. They are sitting together. And we take pride in knowing that his concept was basically, was introduced, was developed when he was working with ISI Calcutta. Is it okay? So, it's well proved. So, what he says, that simply if you have a design and you assume that as there is a design department, quality is assured, it's not that simple. What you have to do, that means as you have a design process, similarly, for ensuring quality of your product, it has to be a parallel process. And if you can develop this parallel process, then only the quality can be built into the product. Getting my point? Separately. You may have a design, but the quality should be treated separately, and there must be a process. So he has very clearly, the mentions that what are the steps involved in quality engineering. This is point number one. That means your attitude must be totally different. You may be a good designer, but as far as the quality engineering considered, you may be a big zero. Absolute. So this is point number one. So my suggestion is that you get the details of quality engineering. Is it okay? Second one is, any product you manufacture, you start using it. You know what is quality of design, you know what is quality of conformance, and you also know what is quality of performance. So ultimate test. The product is put to use, and the user and the customer, whether are getting satisfaction or not. That is the ultimate test. Is it okay? So now this is the entire process. You have a manufacturing process. Beyond manufacturing, there are also many other processes, and ultimately the product reaches to the user. Right? So depending on the type of product, you have different kinds of the control stages you have. Like for the industrial product, you have many kinds of stages. Like you have your warehouse, then you have your the stockist to ultimately the retail stage, and the retailer picks up. Or in other cases, like say industrial product, directly from the stockist or from the warehouse you are importing, so you get the items. Is it okay? X factory. Okay. So, but ultimately the user certifies. Now the question is that during entire process, can you name a single product which doesn't have any cost? Cost to you, cost to your plant, cost to your society. Is it okay? And if there is a cost, there must be some kind of loss. Is it okay? Like say, suppose during the process of manufacturing, there could be lots of risks. There could be, the negative consequences on the systems, including the human, has to be there. Is it okay? So these are all the loss elements. Is it okay? So starting from say inception to say the delivery, the entire process, you identify there are many other activities you carry out to get the product, to ship it to the user. But simultaneously, there are many other, non-valuing activities, cost-adding activities, loss-adding activities. So what is his definition? The definition is that in terms of the loss you generate, you need to define the quality. So what is his definition? Definition is a very unique one. Is it okay? It's not just conformance to specifications. It is what he says, that the quality is the loss to the society after the product is shipped. This is the exact definition what he writes. There is some modification in his definition. Right? That means what he says, that I produce the product. Okay, it's in a finished good state. Then the product is picked up by the user, or you send it to him, and he starts using it. While he starts using it, there could be many types of complaints, there could be many types of inefficiencies inherent in the product. Is it okay? Now this is to be converted into the loss. What he says, the loss function. That means for any product you generate, you have to create the loss function. Now, the concept of loss can be interpreted in 100 ways. You have in your mind one type of concept, I have in my mind another type of concept. Now both are right. But when you are running an industry, this loss or whatever the non-valuing activities you are bothering about against which you are going to identify against a particular product, this must be converted into monetary terms, and that he does. Otherwise, it will not be accepted by the industry. You talk many things about inequality and deficiencies and all those, but as far as there are many parties involved, many types of losses. But you must be able to convert all these losses physically, which you can understand, into monetary terms, so that everybody can understand this one. Are you getting my point? And that he does. So this is a revolutionary concept. He says any product you name, like product, along with the product there are values, but there are also harmful side effects. Like the medicine, it's a product. Can you name a single medicine which doesn't have any harmful side effect? No, name. Similarly, medicine is also a product. Similarly, someone raises a question. Say, my product is the bottle of whiskey. So what is its function? What is the functional value of whiskey, alcoholic drinks? It's not acceptable in India. Indian social system doesn't permit alcoholism. But the products are there. It's an industrial product. You tell me what is its functional value? What is the functional value of this one? There is a functional value, positive, isn't it? There are also negative features you can identify while it is getting produced. This is okay. But what about this product? He was asked this question. Sir, you are saying that the product must have a loss. Now, if the loss is less, you say that the quality is better. But when you talk about alcoholic drinks, what is the loss? Yes, it is loss. Loss to the family. You get drunk, you start beating wife, you start beating, killing children. They're all there, everywhere. You ruin your family. So, sir, the loss is 100%. So, why do you take drinks? Why do you take drinks? And not only here, throughout the world, wherever the drinks are taken, the family is ruined, either today or tomorrow. There are hundreds of millions of such cases. So the society is really concerned about, and through ages, thousands of years. So what is the positive point? Why do you take drink? Because I want to get intoxicated. So this point was raised to him. That means this quality is big zero. But still, it is being produced. There are hundreds of companies, they are running. They are making billions of dollars. Isn't it? So how do you justify your existence in the society? How do you justify?
Conflict of interest.
So what he says, that don't, when so long it is accepted as industrial product, don't bring in That's a compromise with a capitalistic system of production. It's not a socialistic system of production. It's a capitalistic system of production. So that's a compromise you make. They say, sir, don't bring in ethical issues or moral issues. You're getting my point. So he is the first time he relates the manufacturing process with the loss function. Is it okay? That's why yesterday I was mentioning that suppose I asked you, is a company representative, sir, which the company produces what? You say, yes, I produce product. But today you say, I produce product, I also produce waste. So waste is a kind of loss. So you admit, right? So this is the second concept. The third one, what he talks about, that is the robustness, design robustness, right? It's like a very simple example. You drive a car, right? If it's a diesel car, you'll find in the hilly terrain there will be lots of problems. There is, but as if it is, the petrol car, it's fantastic. It is okay. But the diesel car, there are lots of problems, right? Similarly, so in the hilly terrain, the diesel car may not work properly. Everybody is feeling. Whereas, suppose you drive a car in Libyan desert, it doesn't necessarily mean that it will work very nicely. Is it okay? So, you change the environment, you change the, the temperature, you change the humidity, you change the atmospheric conditions, the dust streams and all, you will find that the product performance is deteriorating. Is it okay? Now this is not accepted. That means, if suppose, with respect to, what are the noise factors? What are the noise factors? What are the noise factors of this system? Which is the unavoidable noise factors. Like definitely, this is a controlled environment. But if you go outside, the temperature is very high, humidity is very high. So we are conditioned. That means our human body as such, as a product, is most robust. Getting my point. When you lose robustness, you become a diseased person. Is it okay? So same concept he incorporates. He says, can you not design a product which, irrespective of the working environment, like when in the 70s the computers were introduced, the computers used to be housed in a controlled, the temperature environment zone. Still remember. Today what has happened? The PC is working in any environment. That means what you say, that the PC is very, very robust. So what is the definition of robustness? That means effect on the performance of a product by the noise factors. Effect on the performance of a product is minimum, even with the existing of several noise factors. Can you ensure that? Is it okay? That means the effect of noise factors on the performance of the product has to be minimum. Is it okay? If you can ensure that. That means I give this product to a child and it throws away. It hits over there. Or you bring it back, it's still working. Is it okay? That means the way the child behaves, it's absolutely noise factors, unpredictable. So there are 100 such products, mostly in the electronics category, we find that they are very, very robust. Is it okay? So how to get into the robustness into the product? So he has very clearly mentioned. Okay. Now, here, so these are the important aspects are mentioned. So in the Taguchi method, the quality is measured by the deviation of a characteristics from its target value. That means any product you design, it's not the mean value. Mean is basically you get from the from the process. Is it okay? Whereas when it's the quality characteristic is a random variable, and when you start producing, That means several, the values of these random variable you get from the process. Suppose 100 units you produce, so 100 values you collect. And out of these 100 values, you compute mu. So that is mean. Is it okay? And with respect to the mean, you define variance, variability, you all know. But here, what he says, that any product you design with respect to its quality characteristic, any quality characteristics, say length or the surface tension or say resistivity or viscosity, whatever, is it okay? Now you must be able to set some target value. Is it okay? And you check for a given unit whether the deviation from the target is really significant or not. If the deviation is significant, you say, you describe the product, you say that quality is very, very poor. And so, and this same concept he applies. I will give you certain examples. What is referred to as the loss function. And he says a particular loss function is most relevant, that is the quadratic loss function. Is it okay? So the loss function is developed for this deviation. Uncontrollable factors known as noise cause such deviation and thereby lead to loss. Is it okay? So if the deviation from the target is more, the loss is expected to be more, and that you have to quantify. There are hundreds of cases he has he has dealt with, and then I suggest that those are all industrial cases. This is not something which comes from some scientist's brain. Is it okay? So my suggestion is that at least the persons who are working in the industries, they must pick up his textbook. And there are hundreds of case studies, all are industrial case studies. You name any good company or well-known companies, they have been adopting the Taguchi's philosophy of Taguchi nature. Is it okay? So, since the elimination of noise factors is impractical and often impossible, you are getting the meaning of this now? Say I drive a car. Now, one approach is, there are two approaches. One approach is, okay, why don't you, start using the product in a controlled environment? Or you try to take some measures with which, the design measures, that, there's some kind of shielding you do, so that the effect of the noise factor, it's simply, there is no effect, it vanishes. Can you do that? Many cases, when in extreme cases you do, but the entire system becomes very, very expensive, right? Like say, in operation theatre design, is it okay? There is no question of, allowing the noise factors, no way. Or say, when you design the cockpit, right, aircraft cockpit, no way you should, design it in such a way, okay, let it be, very robust design. There will be noise factors, so the pilot will not mind. That sort of situation we are not talking about. Getting my point? Those are extreme cases, and for those cases, definitely, even if it is an expensive one, you have to bear. Getting my point? But there are hundreds and thousands of cases, the product, industrial product, if you apply the same method, right, come whatever may, why don't you come over here and work in an, the product will fail, but you have to, sir, work within the air-conditioned room. Okay, this sort of sermon you never hear. Is it okay? It's impractical. Is it okay? Like many kinds of field studies we do, field studies, and you need to use many kinds of measuring instruments. Is it okay? By the underground or the overground, anywhere. So this makes sure that these measuring instruments, okay, do function properly, even in extreme environments. Like what you have found, like in the open cast mine, there are hundreds of different types of manual material handling systems we have, but they are all functioning properly. Getting my point? Or so there are hundreds of cases, like in any construction site you visit, right? So lots of equipment they use, but these equipments are running perfectly all right. So these are several examples of a robust design. Okay. So the Taguchi method seeks to minimize the effects on noise and to determine the optimal level of the important controllable factors based on the concept of robustness. Right? Any questions you have? Do you have any questions? Questions are light. Any questions? No questions? Now, here the definition is from the time a product is shipped, as if there is no loss during the manufacturing process. So this this definition has been modified by several other researchers. They say that when you try to calculate the loss, not only the loss you calculate from the time the product is shipped till it reaches the user's place, but also during the manufacturing process, there could be inefficiency, there could be wastes, okay, there could be wear and tear, loss of material. These also need to be considered. Is it okay? So it's a total, the cost model we prescribe. Taguchi attaches a monetary value to quality. Otherwise, no, the industry people, they will say, it just goes over there, it goes over there. It comes over there, it goes over there. So the industry people, definitely they are in a business to make money. What are the the two specific objectives of running a business? What is the main purpose of running a business? To make money. That's point number one. But there is also the second objective. What is the second objective? If your only objective is to make money, very soon you become a trader. You lose your identity as an industrialist. So what is the second characteristics you must have? That means you believe in the concept of continuous improvement. Today you are using a method, tomorrow whether you are using a better method. If this attitude is not there, ultimately just you try to make money, but you will fail, and you will fail miserably. There are hundreds of cases. So Taguchi attaches monetary value to quality. It's very, very important, because ultimately your objective is to make money. Okay? The Taguchi concept of quality loss has been extended by Thacker to include the loss to society while the product is being manufactured. This point I have already mentioned. This is the loss function. Okay? This is a quadratic loss function. So, if the quality characteristics is y, this is say y, target value is m, and as there is a deviation from the target, the loss is incurred, and the function is quadratic. That means the quality y at the target value m, then the loss l is minimized. That means if you can produce in and around m, right, then the loss is minimum. The main example I tell you, or the case study, that is the Sony TV. Sony TV. These days, previously used to say black and white TV and color TV. This we say only TV means color TV. Okay. Now, the Sony TV is produced in Japan, is also produced in US. There are two plants. One plant in Japan, another plant is in US. Now, the US plant believes in the traditional concept. That means for a given quality characteristics. What is one of the most important quality characteristics of any TV?
Yeah.
Display, converted into the engineering specifications. Display is fine, but this is qualitative. What is that particular engineering specifications? What is that for? Pixel, but color density is more important. It's a color density. There are many other factors. As far as so against each but the design is Sony. Design is same, but the production system is different. Attitudes are different. Now in US plant, they have a traditional approach. What is that approach? Like say against the color density, you have the upper specification limit, lower specification limit. And you have the nominal dimension. You know what is nominal dimension? It is a midpoint between the lower and the upper, two-sided specification limits. Is it okay? Now, what do you say that any value very near to say the nominal dimension or very near to say lower specification limit or upper specification limit within the range is acceptable? Is it okay? So this is the crux of the matter. Can you hear it?
Yes.
I'll just use some. Okay, here. Just let me explain this. Oh, it's remote control, not here. The system fault. It's design. Very interesting. And if you know this, if this concept is made very, very clear, you know what is loss and what is robustness. Same. Okay. But there is no lighting here. It should be illuminated. The board. See, the board is not illuminated. You are getting my point. Like here, what you will find, there are street lights. There are street lights. When you drive the car, you will find the roads are all dark. So what is design? I are getting my point. The main purpose is get lost. Means this should be focused so the roads are illuminated. Surface. The surface is not illuminated. So what is the purpose? That means what you see when you drive the car, you can't see other car. So you have to use the highway. You are getting my point. You will find everywhere. This is the case. Okay. So here is, so there should be some illumination over here. Anyway. Okay. Now here, see Sony, I can't get an access. It's killer. It's maybe for someone whose height, the stature could be Amitabh Bachchan's height and have an access. But for it, what?
If you can write it with you.
That's a different one. It's a restricted one. So you feel free. Absolutely. Your hands and these feet are basically natural system. Move freely. Here in extreme cases, in a sitting posture, okay, brain work, you do that. But here it must be free floating one. Getting my point? Everywhere, this will be followed. Be natural first. When it is not possible, it doesn't serve the purpose, then you opt for this one. This cannot be the first choice. Okay. So, anyway, so is this a noise factor? Yes. So long you have to, you're bound by all these factors. You can't go beyond this. These are noise factors. Is it okay? So I have to be very, very robust. And even if such difficulties are there, I must work perfectly. That means the effect of noise factors on my performance is minimum. Is it clear? So anyway, so now here, Sony USA. And here says Sony Japan. This is the production system. This is also a production system. But this production system starts only when you have the Sony design. If there is no design, there is no point. Okay, so they have designed this, the Sony TV, and it is in Japan, and they are producing over here. So the specifications remain same. But the condition, the production system over here is different. It's traditional. So what they have observed, they are producing Sony TV in thousands of numbers. Again, right. Effect of noise factor is not robust. It's dried up. So okay, it's a parameter. That's a parameter. directly affecting. So here it is the performance is affected by the process parameters. Is it okay? Not the noise factors. So now I am checking it, that whether parameters are all like that. Okay. Now again, this is no fresh, all are dried up. There is no re-inking facilities. Ours is a very poor country. If you visit US, for such paints, there are re-inking facilities over there. We are not doing it. We are throwing away. What is this? Re-inking. You can do it 100 times. Just you put it over there, do it like this. After 5 minutes, it becomes wet. We are not doing it. They are the wealthiest of the country, wealthiest of the nation. US is wealthiest. Check their total raw materials content and all those. These are trying for the last 10 years. Why to bring in, the re-inking systems. But then again, there is a lobby. They say if you have the re-inking, you see, so their sale will be affected. So whenever I ask this to my supplier, he looks another way. This is there in the business. Is it okay? That means you want to improve your quality systems, you will be prevented to do that. It's not that $1 funny. Ultimately it's the micro level. The performance will be just. Who bothers about all this lighting and all those? Ultimately this is your planning medium, no? What is it? It's respected everywhere, in any culture. You go to any place, any university. This board will be there. In different forms. Anyway, I'm unable to explain in fact. Time is being wasted. Now, the Sony Japan, the performance is like this. This is USL, this is LSL. The quality characteristic is say color density. So 10,000, the pieces to produce, units. And then this is your target value, M. Value deviations. What is the point? That this is your distribution. 10,000 or 100,000 values. Distribution. And whenever I say it's a distribution, that means the variation is due to only the noise factors. That's a basic condition. So there are no variation. Okay. Whereas in Sony US, the performance is like this. It's almost a uniform distribution. It's like this. So here it is M, here it is USL, it is LSL. Okay, same goal. They are different. Which one is better? Which one is better? What is the inherent, the concept or the concept underlying over here? That means any value here or there or here, they are treated same, all accepted. Is it okay? Or say the value is just over there and over there. You are in a confused state, borderline case. How to resolve this borderline problem? There is no such problem. You can't have, even there could be many sorts of empirical relationships and all, but that is true only for a given situation. There is as such, there is no theory. Is it okay? How to resolve this borderline cases? Okay, thank you. Now, so this is, so it is almost uniform distribution. What do you find? What do you find? That this is say beyond say plus minus 5%, hardly say 20% of the product. Whereas here plus minus 5% from the target value, plus minus 5% from the target value. It may be as high as 70%. Is it okay? Now there is a concept called unit to unit variation. This has been highlighted by Taguchi. I have, there is a concept similar machine and identical machine. What is the difference? Can there be existence of identical machine? Like suppose you have lined up two Lang lathe. Are they same? absolute design specifications, everything same. But it doesn't mean that they are same. They are just similar. They are not identical. Is it okay? So even if you have, say, 2 milling machines installed, okay, now both are different. So this is referred to as unit to unit variation. This will be there. Like say, I purchase, you know, this particular, what you can say, laptop. You purchase the same laptop, same design. But your satisfaction level may be one level, my satisfaction level may be different. So there is a difference that is referred to as unit to unit variation. And why there is a unit to unit variation? Because of the noise factors. Now, can you suggest a scheme or the design scheme as well as the production scheme with which, you know, you can minimize that unit to unit variation? Is it okay? That means unit to unit variation, like Belgian glass. All glasses are absolutely same quality, brand. Unit to unit variation, there is hardly any. Is it okay? That is to be ensured. In many cases, what happens in industries today, that depending on the type of customer, we, you know, produce the product. There are hundreds such cases in fact. Everybody knows. All the salespersons know. Even the, you know, the persons, the production manager, he knows. Is it okay? So who is an important customer? Who is not? Is it okay? This concept remains. That means depending on the volume of business you have with one particular client, accordingly you set of the quality. This approach is totally wrong. This is not at all a Western concept, and this is not at all a scientific concept. Is it okay? But this is happening. So here, so what is better? Definitely this is better. That means on this portion, the 30% over here, for 30% of here, the performance they have observed, the performance is really significantly low. Then a unit which you get very near and in this zone. Is it okay? Now, this is the traditional response. That means what they say, that if I produce within USL and LSL, now I will have a loss, but the loss is minimum. This is a loss, y-axis is the loss. But as soon as you cross this limit, that means it goes up. It's like this. So it is like, you know, the goal post, but not for the football, but for the rugby. Is it okay? But if someone asks you, that okay sir, when it is within USL minus delta, there is hardly any loss, the minimum one. That is the traditional concept. As soon as it goes beyond this, it is not acceptable. How do you prove it? That this has been going on. But there is no proof. But this is a traditional one. It goes up. Where's the root cause? Failure of the system. Where's the root cause? The level. Okay. Changing the level. The root cause. Okay. So this is basically the concept. Whereas the Taguchi says that as soon as you deviate from the target, forget about USL or LSL. If it is at the end, it is minimum best possible performance. If you get the best possible performance, that means the loss is minimum. That's the basic assumption. And as you deviate, the loss is more. Quantitative. Is it okay? So this is the concept of loss function. Quantitative loss function. Is it all right? So okay. Is all right? I don't know. Right. Okay. Now,
It's screened on.
Screen. Any questions you have? So the performance of the Sony USA was not that good. Is it okay? That means there have been a lot of complaints from the customers regarding the performance of the TV. So there are many such cases, not only with respect to the TV, but you name any product, you follow the traditional Western approach and you follow the Japanese approach. So the Japanese approach is based on, scientific work. Okay. Now, what he says, that the entire Taguchi method is having three stages. Alright, okay. So there are three steps. First one is the system design, second one is the parameter design, and the third one is the tolerance design. Right? And the system design, what you do basically, that means the basic, the design of the product, the bothering about. Is it okay? And in any, the complete design, there will be components, there will be sub-assemblies, and there could be, different modules, right? And the interrelationships. So this is a typical, the design output you get. Is it okay? And so this is basically the systems design part, right? After you get the product, then what do you need to do? Particularly for the machine, for the equipment. Now the machine is to be run at a correct setting. That means, what do you need to do? During the parameter design, you need to identify the parameters of an equipment, okay, of your choice. Once you identify, then with respect to the performance of the machine, say output of the machine, right, like some turned pieces you need to produce from the machine, okay, or say your operation is drilling hole. Now when you drill the holes, that means the inner dia, the tolerances must be specified. Is it okay? So these are basically the output, or sometimes if you mention with respect to the product which you produce from a process, the particular quality characteristics, this is also referred to as the response value. Is it okay? And these values are changing. There will be variability in unit. Now what do you try to do? That means the variability in the output, okay, you try to relate it to the values of the process parameters. Is it okay? That means suppose speed, feed and depth of cut. These are the three process parameters you have identified. What do you need to do? That means in order to produce say 1000 pieces, okay, acceptable pieces. That means with respect to certain suppose surface finish, right? You have a standard, you have the specifications. Now in order to get that particular value, what will be the values of my, the speed, feed and depth of cut. So this is the whole concept, the whole process is known as parameter settings. In fact, knowingly or unknowingly, all the maintenance managers or the maintenance crew, they have been doing it. When the machine is getting installed or the plant is getting commissioned, so essentially those parameters are set, parameter values. So the whole process is known as basically the parameter design. Is it okay? Once you do this, suppose I say that my parameter values is, suppose RPM you say 630, or say, similarly the feet or the depth of cut you mentioned, one single value. What is it called? That means the point estimate. If you have a point estimate, what we have observed, we have studied one, a detailed, the furnace, okay? And when it produces the charge chrome. What we have observed, that suppose you just specify one value, is it practical? It cannot be practical. So always, the point estimate and the interval estimate. That means instead of saying that set the value at 500 RPM, why don't you say that set the value within a range between say 500 to 700. That means the interval estimate is always preferred. Is it clear? So that exercise you carry out when you go to the third stage, that is called the tolerance design. Is it clear? That means, suppose I say that problem. Okay, just you raise it, you raise it. Just take 10 minutes. So y is the response variable. So y is say function of say x1, x2, x3. You determine at the parameter design stage, you determine the values of x1, x2 and x3 in such a way that the value of y is acceptable. Is it okay? This you do, the whole exercise. Obviously experimentation is required. That means the Taguchi method you apply at what level? At the design level. Now what are the stages in design? What are the stages in design? As an engineer you must know. First one is the preliminary design. Everywhere it is followed, throughout the world.
Conceptual design.
First one is conceptual, some ideas, and then what do you do? That means preliminary design. If you pass the preliminary design stage, then you go for the detailed design. Once the detailed design you pass, then you go for the prototyping. And prototyping, when you get the prototype, you carry out the tests. Is it okay? And constantly review, regarding my point. But if you reach at the prototype stage, that means, what you need to do, you need to verify. So at the prototype stage, you carry out this exercise. Are you getting my point? This is, the Taguchi method, even at the production stage, what we have observed, that the production stage it can be applied. Is it okay? Like the material handling systems you have, with the bunkers, and then the furnace, and then, that heat you get, and it goes to the casting. Is it okay? Now there could be some 120 parameters of the furnace you can identify. Is it okay? And when you reach the raw material handling, right, again, till it reaches the bunker stage, then there could be many other parameters. Now the problem is that can you save those values? Those are basically the x1, x2, x3 up to xn, right? So you determine those values in such a way that the value of y is acceptable to you with respect to the performance. Getting my point? That means the y, all these values are related to the performance of the product. Okay. Now, instead of having one y, there could be m number of y. Okay. Obviously. This is also possible. That means from single response, you have a multiple response. And the real one is a multiple response. Can you, name any single product which is having just one kind of, the output or the response? It is just not possible. Is it okay? So this is the basic equation. So first we start with, single variable or single response, and then you move to multiple response. Is it okay? So for single response, how do you get these values? x1, x2, x3, definitely through experimentation. And here, everywhere it is followed. You visit any research lab, any R&D lab, okay, anywhere. So they are scientists, they are hiring R&D, the scientists that have been carrying out this one. Okay, so what they do, that means I determine these values. Now again, I am saying that instead of having, just specifying one estimate at the tolerance design stage, you say x1 plus minus delta x1, y x2 plus minus delta x2. That means etc. Like this. When you reach at this level, that is also possible. That means really it is a feasible one. Whatever suggestions you make, it's feasible. If you just give one value, it's not feasible. Now, here you make some compromise. What you say that, okay, I know it very well, that if it is exactly at x1, the nominal value, the performance will be at y. Definitely. Simultaneously, you have to do that. So, and there is an interrelationship between this, you just consider. That means the individual values as well as the product term. Is it okay? Interaction effect. We consider all those details we are not discussing right now. So now, what do we do that there will be, if you change it from x1 to x within this range, x1 plus minus delta x1, obviously this remains y plus minus delta y. Okay, so if suppose it starts working at y, say plus delta y at one stage, obviously the performance will be slightly deteriorating. Best possible performance you will get only at y. But if it becomes y plus delta y that you prescribe, you get definitely an inferior performance, but that must be acceptable to you. For a very, very sensitive instrument, or say the product, even such the deviation is not allowed. Can you name such a product where even say 0.01% deviation is not allowed? There are many such products.
I think last 6.
Like say aircraft. Okay, each and every component in the aircraft, the super finish, and almost it is identical. Is it okay? One Boeing 747 and the same model you bring in, what do you find? It is absolutely identical, not only similar. So that is the perfection. Similarly, say the tablet or the capsules. Okay, just think of when unit to unit variation. So they are getting it from the process. And it doesn't happen automatically. Just simply you get the blueprint and you start producing. It never happens. The Taguchi method says, okay, the designer, let them do their job. But here, when it comes, when you try to achieve the quality of conformance, definitely, you must believe in the Taguchi's method. Is it okay? That nothing comes automatically or from, say, in the vacuum. So you have to follow that quality engineering approach. So this is entire exercise you carry out, and there are lots of scope for improvement. So essentially, the Taguchi method is a quality improvement technique. Just make a note. Under quality, you will come across several such tools and techniques. Taguchi method is one such tool or technique which is referred to as a quality improvement tool. So objective is to improve the performance and with respect to the performance of the product. Okay, now please no more writing on the board. Okay, writing on the wall. Right. So 5 more minutes I'll take. So when Taguchi has used a particular term called signal to noise ratio as a measure of output. Is it okay? So there are details, so time is short. So just you make a note, signal to noise ratio. And what is our product as far as asset management is concerned? Our product is tools. Our product is machineries, the equipment, the system. Production related equipment. More specifically, you should corner yourself. the production related equipment. And it could be sometimes a system, like the transfer system. It could be robots, it could be AGVs, or it could be material handling systems. When I talk about production system, it's not only the machine where the metal cutting takes place. It consists of what? What are the elements, components of production system? Material handling. Without material handling, there cannot be any production system. Machines, material handling. All are considered to be the equipment or the system. So the uncontrollable factors are known as noise factors. So this you can have a look. And this diagram is very important in fact. When you talk about product development, there are 3 stages, I have already mentioned. The first stage is product design. Second stage is the process design. The equipment you have to design. Today you are not designing, but this is being designed by the Europeans. Okay, that's why you feel free. But suppose the Europeans, they are designing their own, right? And the last one is the manufacturing, interrelated. Now, the source of noise. So there are 3 kinds of noises. Environmental variables like temperature, humidity, dusts, uncontrollable. Second one is the product deterioration. Wear and tear, unavoidable. This is a noise factor. Third one is the manufacturing variations. Like I engage person X on the machine. He is having one type of scale. In the next shift, I engage person Y. He is having different types of scale. This variation is unavoidable. So this is treated as noise factor, unit to unit. Similarly, there are many other factors. Now, at the product design stage, if you are careful, now the counter measures against environmental variables, against product deterioration and manufacturing variation is possible. Is it okay? That means design is very, very important. So at the design stage, at the prototype stage, the person who is involved, he must be knowing all this. Otherwise, if you miss the bus at the design stage, what happens? There's a concept called committed cost. If you do not apply the quality improvement technique at the design stage, and then when it crosses the design stage, you reach the process design stage of the manufacturing, that means 80% of the cost is just committed. Okay. Means, suppose the total cost is 100 rupees. If you miss the design stage, 80% of 100 is already committed. Now you have to deal with just 20%. This is also one of the reasons you will find in many cases, you as a young engineer, you at the production stage, you spend a lot of time, lot of effort. But then again, always you keep on, they're asking you, sir, you have been putting a lot of effort, but what the company is getting? This is a real experience for anyone. Okay, you are doing it, so nice, but this is at the macro level. But it doesn't, affect the system as a whole. So there could be many reasons. The one reason is that is very, very vital. That means already the 80% or 90% of the cost is committed. So what you can do at the design level, these activities you cannot carry out when you reach the production stage. Okay, so the countermeasures is not possible. So what do you do? At this stage, the process design stage, countermeasure against environmental variables, is it possible? No. For the product deterioration? No. Because already you have selected the materials. Right? As far as design is concerned, you have to select the material. So, one type of material, one type of deterioration level, which is unavoidable. So, countermeasures is not possible. But still, we have hope you can have countermeasures against the manufacturing variations. So, the scope is limited. Right? So, what he says, the Chakravarti says, that we try to apply the concept at the design level. Is it okay? And then the maximum benefit you will get. Similarly, at the manufacturing stage, countermeasures not possible. Countermeasure against product deterioration not possible. But of course, manufacturing variations possible. So you will be just dealing with the 20% of the total cost. Okay. So time is also loss functions. I have already discussed all these details. This already I have explained. This is the loss function. This is the goal post or rugby. Right. Not for the football. And these are different types of quality characteristics. And these are the typical calculations we do. And there are many assumptions. The target is best. The two-sided specifications, right? Means the upper specification limit or lower specification limit or tolerance limits you have. So the nominal dimensions is the midway between upper and the lower. That is assumed to be the target. But as I have told you, that the target value can be specified independently. Is it okay? And then you check that whether the value of mu and the value of the target, they are same or not, or is there any significant difference between these or not. So this is a additional target is best, this sort of calculations we do. And this is here, there is a comparison between two cases. I have already told you, like Sony US and Sony Japan. Now this is also a very important concept. It's unfortunately this is missing in 99% of our manufacturing systems. Everybody knows about the tolerance, customer tolerance. When we talk about the specifications, essentially we mean the customer, specifications. But if you want to, work within the customer tolerance, what is required is that within the factory systems, within the manufacturing systems, you must be bothering about the manufacturing tolerance. So if your actual specification is this, M plus minus, okay, delta. But if you, at the factory level, suppose you produce this, what happens that when it goes beyond factory, there could be many other noise factors. So ultimately when it reaches to the user, the user state, what happens that the tolerances will be more. So most likely we will be dissatisfied. So what do you do? That means considering the factors affecting, the tolerances, when you go beyond the factory, so your manufacturing tolerance must be significantly less than the customer tolerance. So it is M plus minus small delta. Is it clear? So, but this is this is very, very important. And so, if someone develops the concept of manufacturing tolerance, right? If he gets to this particular concept, yeah, definitely, then knowingly or unknowingly, he is applying Taguchi method. Is it okay? So, I'm closing it now. And so there are procedures, there are examples. Those who are interested in going through the details, definitely they are all welcome. Is it okay? It is a very important concept, manufacturing tolerances. And his entire concept, he tries to apply in a manufacturing setup, production setup. And the production setup consists of only what? The assets, the physical assets. Whether it is a machine, whether it is a material handling, whether it is a tool crib, whether it is other manual material handling, or the mechanical aids. So everywhere you will find there are different kinds of assets you will be using. Is it okay? So that's why this is also one of the reasons why Taguchi method is well adopted in industries, because he talks about the production system. Is it okay? So small is better. There are many such quality characteristics. Where this is larger is better. Larger is better, like the tensile strength. The minimum value is 3000 kg. Now, as more than 3000 kg is always better. It's like this. So there are many examples. These are typical examples. The time is short. And how to convert this the loss function into monetary equivalence, monetary terms. Also well explained. Okay. So I stop here. And any questions you have?
These shows the total costing of that, that OEE and how it actually influences the over, I think, let me copy the other file and check whether it works. It has been brought here, and the good thing is it is in Excel sheet, so we can actually change also. Right, so you look at this, that, see, this is the planned hours, 8760, and maximum production is 50. So this one is, because of size, this is not showing. So theoretical production will be multiplied by the maximum production per hour into the planned hours in a given year. Alright, so that's the total production. That's the first part of the calculation. Then the second part is the OEE, which is your availability, performance and quality. So let us assume that availability is 0.77, performance is 0.86 and quality is 0.91. So multiply the 3, you will get the OEE at around 0.6. Right? Actual value will be slightly around that. So this is 0.6. So these calculations are shown at little bit round off. And thereafter, let us say that we have, this is the theoretical production that we have. If you multiply by this, maybe it is around 4 lakhs or so. So if you multiply by this, then you get the actual production. See, OEE is like an efficiency. So if you see the total hours and if you see the total production that is possible, then this is the total theoretical production. OEE, if you see that OEE will give what is the actually you are doing, isn't it, from that point of view. So if that is the actual production, now look at it. Suppose the price is 0.6 and the variable cost per unit is 0.417, then if you multiply the two, you will get something called the contributory margin per year, alright, which is the multiplication of the two, which comes to 0.25, and this multiplied by this actually gives the contributory margin per year. And there is a formula that says that if you compare this margin with the fixed cost, this margin should be at least equal to the fixed cost. All of you know this concept of this break-even point and these things, yes or no?
Yes.
There is a fixed cost and there is a variable cost, and the total cost will be fixed cost plus variable cost, and the contribution of the your revenue, that will be going like this. The point where it cuts, that's the break-even point. So at least that much volume you must produce, that is called the break-even volume, where you have no profit, no cost. Beyond that only you can start making profit. So in simple words, this is done in this way, the calculation, that we find out the variable cost per unit, you find out the contributory margin and multiply, then that gives the contributory margin per year, and that should be at least equal to fixed cost. And what are some fixed cost component? Direct maintenance cost, depreciation of the fixed assets, and the other fixed costs. Right? These are the three major cost components. When you add those three, then you get the total fixed cost. Is it alright? And there are other costs like your fixed assets. This is the total asset value, and this is the net operating working capital. Right? Net operating working capital. So these two figures, when you add, then that is what you get the capital employed. This is the total capital employed. So these are the three figures. That is, number one is the profit, which is the contributory margin minus fixed cost. The revenue is what? Revenue is that this price 0.6 into the actual production. That is what you are selling in the market. So this is what is called revenue, and this is the capital employed. So these are the three figures. Based on the three figures, we are actually calculating three ratios, and those three ratios are shown there. Let me just drag it slightly. Yes. Now all the figures. Alright, so now you have all the figures. Actually you can see, and you can now observe that when the OEE is at that 0.6005, these are the three ratios. That one is called profitability percentage ratio, which is that as a profit by revenue in percentage. Then the capital turnover rate, which is the revenue by the capital employed, and finally the return of capital employed, which is the multiplication of these two figures. It's alright. So all the total picture of the company is before you. That is, we have shown the OEE, we have shown the production, we have shown the costs, different costs, and then three major parameters: profit, revenue, and capital employed, and finally the profitability, capital turnover rate, and return of CE. There are further financial ratios that are available, because when you say profit, there are profit before tax, PBT, profit after tax, PAT, and those other kind of things which we are not going into. Now my question is that, first, can you tell me that how much a little change on OEE, how is it going to affect the at least that profitability ratio? Let us say if the OEE is changed by 10% here and 10% there, what would be its impact? What would be its impact?
Same.
Same means, suppose OEE is down by 10%, the profitability remains 7.15. What would be the change?
Again, 10% return.
Will it fall exactly 10%?
It will increase, right?
Yeah, because it's linear.
Is it that way? Linear, not linear, because revenue is also going to change. If the actual production changes, the revenue is also going to change.
All parameters will be adjusted.
Yeah. So just I want you to at least tell me what it is. What would be the impact? Let us say we change the OEE 10% down. Let us see that. We can actually see, because this is when. So all these three figures you can write down: 7.15, 0.95, and 6.81. So please note those three figures. Now what I am doing, I am going to change. Let us say which one? Any one we can change. Let us say we make the quality 0.91. We change it to, let's say, 0.82. Or we simply multiply this by 0.9. Right?
Equals to sign.
So what has happened?
Yeah, equal to sign is required.
Yeah, that is equal to sign is missing. See the effect. So what is the change? Just look what happened. Look, see, all we did a change here is that quality yield, we changed it by 90%, we made it 0.82, and therefore the OEE, which was 0.6005, has now become 0.5404. So it has become 90%. That much is down, OEE. And look at this effect on these three figures. It was how much? 7.51. Now it has become 3.32. So it has become reduced by more than 50%. Alright. And what is its effect on these?
Around 10%.
And what about this return on capital? What was the original figure?
6.8%.
And now it is 2.84. So look here, even a 10% change in the OEE has caused a 50% fall in the overall ratios, more than 50% fall in the overall ratios. Is it alright? So similarly, another calculation, let us say if it goes 10% up, so instead of 0.9, if it becomes 1.1, let's see what is the change. Look at the change. So here it's 0.91, so it's like it is some rounding of thing is showing. So now OEE has become 10% up, 0.66, and look at all the effect of these. The profitability is 10.3, this is 1.05, and this is 10.8. So now it is a 50% improvement. But see, that has earlier it was 100% down. 7.15 came down to at least half of that. But now the improvement is not that much, it's not double, it is 50% improvement. So a 10% change in the OEE is leading to 50% change in the profitability. Right? It's up by 50%. Is it clear? So, you know, it's not exactly it will be same everywhere, it depends on the value, but exactly the kind of thing I am trying to show is how the performance or the earning power of the company is dependent on a slight change of OEE. How that, you know, is so much sensitive to this operating, that overall equipment effectiveness. So let's bring back that figure once again. Okay, now you please do this small exercise that let us say that you know a change of OEE. Alright, see, suppose you make a small change in OEE, that is a 10% change in OEE can bring a profitability improvement by 50%. Alright, how much is that same change can bring? This small calculation, if you can do, please do this. This will actually give you an exercise that look at these figures, so they are all with you. How much the change in price or the change in the maintenance cost, alright, is going to bring the same change. So 10% change in OEE is going to make a 50% improvement on the, so that's what we have already seen, a 10% change here leads to a 50% rise here. So how much of this price per unit should you change? Alright? Or by how much, let's say that maintenance cost, if you bring down to make the same change. So obviously there are other costs we cannot make much changes, like depreciation of fixed assets. Can you change it? Cannot change it because depreciation is predefined. You just cannot do anything on it. Alright, you cannot do anything on it. Can you do anything on other fixed costs? Yes, you can. You can, but again you see all these other fixed costs are already decided. It's probably the cost of marketing, transport, and so on and so forth. So much of it is not in your control. Is that right? So some of these fixed costs are not really in your control. Yes, the variable cost per unit probably you can look into your machineries and many other things. But let us say that you have two controllables. One is increase price, another is reduce the maintenance cost. Alright. So how much do you think the effect will be? At least that price increase, just work out. Suppose you make a 10% price rise. Just make a small calculation and see how it changes. It will give you a broad idea of the whole thing. Is a total picture clear to you that how the whole thing is affected, or anything not clear? Have you understood all the factors? Right? That fixed cost components are depreciation, other fixed cost, maintenance cost, and assets and waste, operating working capital, they are actually capital employed.
5% and
Alright, see these assets are coming in 2-3 places, that the actual value of the fixed assets, that's part of capital employed. So this is where the asset and the depreciation of assets, that's also another thing, that's part of the cost. So that is actually reducing. Although it is a notional figure because you are, this chair is with you, it was still with you. Alright, but you have to take it as a cost. Why can you tell me? Why do you think that, see this chair is here with you last year. Next year also the chair will be with you. So any depreciation that you put on this chair, why should it be taken as a cost?
make some expenditure.
Maybe, so what? Chair is with me anyway. Then why should the depreciation cost be taken? See, we had the machine last year, we have the machine this year also. So why that depreciation cost should be considered?
The quality has decreased as you said.
It was very simple, is that you have to replace the chair at some point of time. Alright, so that cost, whatever you incur, that cost you are actually accounting in number of years. As simple as that. Alright, so, okay fine, and you made some calculations, so can you tell us a broad idea? A 10% change in costs and a 10% down in maintenance cost, what would be the effect? Same? Same means what? 50%. So like the same thing that happened earlier. So let us see that. So what am I going to do now? I am going to change the price. So instead of 0.6 we make it 0.66. Alright? And enter. And then we see what happens. See? 10.3, 1 point, more or less similar. So 7.15 to 10.3. Not 50%, slightly less than 50%, 45% or so. Is alright? So that's about the profit. So let's change it again to 0.6. And again, another thing I said that direct maintenance cost. So 9469. Let us say we reduce it to
47, 30%.
how much?
47, 30%.
Direct maintenance cost is also we reduce it by 10%.
0.9.
But not much change. Alright, so you see, this is not going to affect much. Right? So it improves the profitability, but to do that, it will not do this thing. So you see, basically, therefore, what is, essentially we are basically getting out of these is that, you can well understand that even a 10% price rise will have many other impact. You can increase the price, but your competitors may not be increasing. So your profitability might become better, but you are that much non-competitive. So question therefore, maybe your other expenditure like advertising and other things may go up, which may actually reduce your profitability again. Alright. So that's where OEE's importance is actually found out. Alright. So this I showed only to highlight on the effect of this. Right?
Yeah, I have a practical question. Actually, every consultant they came for this consultancy for any organization.
Yes.
They want to cost cutting. First, they will cut this maintenance engineers or maintenance personnel. Basically, as per this one, it is clearly shows that you will not get that much benefit at the end. You are losing people and also expenditure. So why they are taking that decision? On what point, you know? Because
No, see, I think probably what you are saying, I'm not sure about it. But let me tell, that will be my next topic, right? In the very next class, I shall be, getting into the maintenance in a better way. Now look here, the maintenance when it started, the essential idea in the old days was simple breakdown maintenance. From breakdown maintenance, it simply went into the preventive maintenance. That is, instead of maintaining at any time, you make a schedule and you maintain at a specific intervals of time, and therefore you do not allow the machines to deteriorate beyond a point. The next thing comes, condition based maintenance or predictive maintenance. That means you monitor the conditions and try to see if the conditions are going a little beyond, then you try to do something, right? These are called predictive maintenance. But today we are actually talking about intelligent maintenance. Is all right? The essential idea is, like we have diagnosis and prognosis in medical situations, the same concept is here, that is, try to monitor the health of an equipment. Is it all right? How good is the health? Try to find out its remaining useful life. Is all right? And look at it from that point of view. So the concepts like intelligent maintenance, e-maintenance, they are all here, and consultants may be trying to tell you that reduce breakdown maintenance, but they are not going to tell you that don't do maintenance. Is that right? So that way maintenance cost will be very difficult to cut down. With all these new things, actually it is only going up. Anyway, we will discuss the next class, right? Okay. Thank you.
So this will be your, the last interaction session today, and the next 40 or 45 minutes, I'll be highlighting a few aspects related to asset management, more specifically to the maintenance and replacement. But before we take up that exercise, let me go through these examples. This is a numerical problem, and as we have been saying that your assets should be robust and assets should be flexible. And when you try to incorporate flexibility in your system, do you have any idea about flexible system?
One question from here.
Yeah.
Let us ask.
But
He is
there is-
asking what is robust. That is his question.
Robust, you didn't attend? In the first class you didn't attend at 2 o'clock? No? Yes or no?
No, sir.
Why?
I'm into the departments.
So before you ask this question, you just discuss that whether robustness has been discussed or not. Robustness, I'll tell you, very simple. You are a young person, isn't it? You are in prime youth. Do you feel yourself to be a robust one? What is your level of robustness? The same concept, basically, even for the equipment or machinery of the system. Are you robust? Normally the youth, the best part of your life, you are very, very robust. You play football?
Yes, sir.
You play football?
Yes, sir.
Yeah. So after you play football for 90 minutes, what do? You just take rest for 15 minutes, hardly, and you recover and go away, right?
Yes, sir.
and you don't mind, isn't it? You go to library, you start studying and all. But suppose I play football today, right? My age is 50 plus. What will happen? I will collapse. And even if I play, suppose I try to play for 60 minutes, what will happen? That I will collapse and you never know whether I will recover or not. I'll go to the blue. Say, okay, there is a high chance. So now, what is my level of robustness? Very low. Your level of robustness? Very high. That means, if you are able to withstand varieties of conditions, but you stand firm, okay, you perform, you don't mind, the traveling, as I'm telling you, 36 hours train journey from Howrah station to BT, okay, without any reservation. Such things we used to do during our time, but you don't mind. That means you're 100% robust. Is it okay? But today, suppose I do the same exercise, I will again collapse, I may die. Is it okay? So, the definition is the same principles we apply with respect to a product. Like say, yesterday when you used to, use your shirt during the childhood days, there was no, the T-shirt or the Tarzan shirt. Okay, and when the Tarzan shirt started, we started using, within say few days, you will find that the quality deteriorates. Today, what do you find? All the textile, the kind of the stitching you have, is it okay? The quality has improved. Ready-made shirts. What does it mean? That means the way you wear the shirts, various persons are using the shirts in numerous ways, but the quality remains. That means the performance of a shirt, okay, is not at all affected by many kinds of noise factors. So we discussed was the noise factors, like the effect of the environmental conditions, the effect of what you can say manufacturing variations, like effect of the material quality variations. So like the kinds of textile you use is superb, like the kind of stitching you use, it's waste. So the test of time. So this is basically the concept of robustness. Like we say, the lathe machine, the central lathe, is very, very robust compared to many kinds of, newly, introduced CNC machine. Very touchy, very sensitive. You're getting my point. There is usefulness of CNC machine, but as far as robustness is concerned, the central lathe is really robust. You're getting my point. So it's a combination. Like, like AGVs you install. So under some specific conditions, it can work. Very sensitive. So it's not that robust. But if you use, say, forklift truck, you have seen, it's very, very robust. Right? So the definition of robustness is that to what extent the performance is affected, performance of the product is affected by the noise factors. And if you can ensure a design in such a way that the effect of noise factors on the performance of a product is minimum, then you say, this is a robust product. Is it okay? So, by natural processes, your system, the human body, is most robust. If you lose your robustness, that means you are becoming sick, unhealthy. Is it clear? But there are other factors, like aging is an important factor. Like at the age, suppose the machine is just 1 year old, robustness is very high. Machine is, say, 25-year-old, robustness is not that high. Is it okay? Anyway, so just sit down. Right. Now, just to go through this statement, customer tolerances for the height of a steering mechanism are 1.5 plus minus 0.020 n. When you write plus minus, that means the two-sided specifications. For a product that exceeds these limits, the cost to the customer for getting it fixed is just $50. Is it okay? Means it is a repairable one. Is it okay? It may so happen that as soon as it crosses the limit, now you cannot bring it back. There are many such cases. Is it okay? But we are saying that even if the failure occurs, or say you bring it back, but some extra cost you have to incur. 10 products are randomly selected from a process and yield the following heights. So individual differences will be there. As I've been telling you, that the variability is a part of the process. You can't name any single process where there is no variability, except in few cases. Like say, even if in a small domain, you may find that there is hardly any variability. As you increase the domain of your work, you will find that the variability increases, the level of variability. Anyway, so these are the 10 values. This is just an illustrative example. So 10 values you collect, 1.53, 1.49. So it cannot be just for each value 1.5, 1.5, 1.5. No way. Is it okay? Because the 1.5 that measure itself is very fuzzy. You are getting my point. Anyway, so 1.53, 1.49 like this. Find the average loss per product item. This is the question. Right. Now I have already explained that what is the concept of the quadratic loss function. Is it okay? So that Taguchi has demonstrated that with the data, this is empirical finding, that the loss function is like like k times y minus n whole square. Right? That's why it is quadratic. So y represents the height of the steering mechanism. I explained that what is the response variable, okay, in the last class. And the k is a proportionality constant. So what you need to do, that means you have this data, that 50 divided by point, so I have this, this is, so first you need to determine the value of the proportionality constant, as usual steps we have. So all these values are given, this is the loss is A, and this is the deviation. So the square of this deviation, that is 0.02 whole square, that means 125,000. Now next is, once you do this, what's the value of, it's not working? So alternative is there, no problem. Okay. So this is your equation. So expected loss per item, now this is the expected loss, and then you calculate these values. Is it okay? Individually you calculate these values. That means your values are yi, random variable, and your target is 1.5. So the deviation from the target, and you square it, and you have that 10 values. So you just get the mean. Is it okay? The mean of this one, that is 3 knots, 0.3 knots 49. And the expected loss per item is 61.25 knots. Is it all right? Now you have to verify, you have to validate. Right? So that part we are not discussing right now.
So it may work from there.
Hmm?
It may work from there.
Is it okay?
I think so.
Okay, now it's okay. Okay. Now the manufacturer is considering changing the production process to reduce the variability in the output. It is always possible. But this may not be the first choice. As far as our country is concerned, it must be the last resort. Is it okay? Before you change over to a new system, make sure that the existing system is fully utilized. Is it okay? So the additional cost for the new process is estimated to be $5.5 per item. Because the more sophisticated the process is, the running cost is more. Is it okay? That is the usual relationship. Now another very interesting the point you must note down. What is the relationship between quality and cost? Is it inverse relationship or direct relationship? Direct? It's direct.
Yeah.
Means if you want to improve the quality, that means more number of features in the product you have to increase. You have to add, and more number of features means more cost. So this is a traditional view. That the first time in the history of mankind, the Japanese organizations, they proved the other way. That means they say there could be numerous cases where the relationship could be inverse. They proved it. And Taguchi has proved a number of times. That means the quality is increasing, but the cost at least remains constant, and in certain cases, the cost is decreasing. Now, in a typical Western approach, till the mid 20th century, it was unthinkable. It was not feasible. The kinds of production systems you have, can't do that. Is it okay? But it is possible only when you apply the Taguchi method. That means, in true sense, the quality engineering concepts. Is it okay? So anybody can do that. Means, okay, sir, I am offering this product with these quality features. Now, if you this is version 1, and if you want to get the version 3, so you have to spend more. If you are in this domain, in this sort of thing, no point in using Taguchi method. Is it okay? You can do this, but you can't capture their market. So this is the essential message from the Taguchi method. Is it okay? The essentiality. So now, what he says, there are ways to do that, and but here, process improvement is a must. And if you go for process improvement, what happens that you spend more on the running cost. Okay, and but if you with process improvement, if the quality improves, the loss will be less. And if the loss, the reduction loss is substantial, then overall you gain. So whenever you try to apply quality engineering, it's a long-term strategy. Is it okay? It becomes a way of life. Then only it is feasible. Is it okay? It takes time. Have patience, and then only you can slowly implement it. Okay. Now, so when the improved process, so annual production rate is given 20,000 items. That means it's a mass production situation, right? 8 items are randomly selected, and their corresponding values are like this. And what do you expect that on an average, the value should be, that means the difference with what? The target value should be, less. Okay, the deviation. Is the new process cost efficient? If so, what is the annual savings? So again you calculate the expected loss, already the proportionality constant that you have already computed, and target remains same, 1.5. And for the new process, so why target remains same? Is it process dependent? Are you getting my point? So suppose your product remains same, but you can turn or you can process it with 3 types of machines. Alternate process plants you have. It can be processed with the central lathe, it can be processed with automatic screw machine, it can be processed with CNC machine. These are there, many options are there. Process plant you are all aware of. Now obviously the target must be same. In many cases what happens? That we change the target depending on the process. Again, in the shop floor, the basic rules are violated. My point. So you must believe in, so obviously who is basically determining the target value? It is the designer, right? And so depending on the process capability, the deviation could be more or deviation could be less. So this is again the same process procedure we repeat. The values are, as in improved process, the actual values are 1.51, 1.50, 1.5, more or less. The values are very close to 1.50. The deviation is less. So obviously the loss will be less. Once we do this, now here previously it was 61 point something. Now it has come down to 23.44. But you need an investment. It doesn't happen automatically, isn't it? So that is also to be considered. So it was 61.25. Now it has become 23.44. So the reduction is 37.81, but you have to incur separately $5.5 per item. So the net settings will be 32.31. It's so simple. And it's more or less it's a deterministic problem. Is it okay? But actual problem is the stochastic one, right? So that always we can do, but let the concept be known correctly. Okay, now next one is the manufacturer decides to rework the height prior to shipping the product at a cost of $3 per item. You already explained what is customer tolerance and what is, say, manufacturer's tolerance or manufacturing tolerance. Is it okay? So manufacturing tolerance should be significantly less than the customer tolerance. Okay. So here, if you find that you set the manufacturer tolerance, when you ship the product, if you find that the value, the actual value is greater than the manufacturing tolerance, is better that you carry out some rectification work or some rework before the product is sent to the customer. Because if you do not carry out this rectification work and you just send it to the customer, in all likelihood, the customer will have more complaints and ultimately the your loss will be very, very high. So better you spend, say, 3 rupees instead of incurring a loss of, say, 30 rupees later on. Is it okay? Let it be 27 rupees, but you spend 3. Normally, we never do that. We take a chance. We say, okay, let it be sent to the customers. If he reports some complaints, then only we'll intervene, otherwise not. So this attitude must be changed. Are you getting my point? So once you calculate like this, then you have all this data with you. Like this is 3, that is the extra cost you incur, and corresponding the small delta, that is n plus minus small delta. This is basically the manufacturing tolerance. So that you determine. So what is the decision is that you just check the manufacturing tolerance, whether the value before the item is shipped, whether the actual value is lying in this range or not, that is 1.5 plus minus 0.0049. If it lies within this range, you send it. Don't carry out any rework. Is it okay? But if it is not, then definitely it is better that you do work. You spend some extra money so that when it reaches the customer's premises, the customers will find the product lying within the customer's tolerance. Is it okay? And he remains satisfied, right? So this is an exercise, simple exercise, but certain concepts you learn. Now, I'll ask just one very specific question before I'll take up that the tutorial. This is just a typical problem. This is a classroom exercise, numerical problem. What do you mean by total productive maintenance? In the name of total productive maintenance, there are hundreds of the lectures or say concepts, or there are many things that there's a problem which, when you bring in this sort of concepts, what happens that it goes to different domains, and ultimately, you may attain those programs, but you miss the point. Many such cases it happens. It has happened to Six Sigma, it has happened to TQM, many places. In the name of Six Sigma, many things are not at all relevant. Getting my point. What do you mean by TPM, total productive maintenance? Suppose I am a layman, I don't know anything. You need to make me understand, very simple language, what is total productive maintenance. You might have heard TPM. What do you do in TPM? What is the basic assumptions in TPM? It's a very, very important, I tell you.
All the activities in the maintenance should be productive. That means either
So it has been, all the activities should be productive. This has been the message throughout.
No, but
Since the factory system, was born.
no, maintenance perspective, maybe the inventory side is not important. He is not at all responsible, or even not.
Now, it is a Japanese concept.
It's a zero defect.
They have introduced.
And
What is the
you have to consider in that point also, and also the operation also to consider the maintenance perspective. As he said, not like enemies, they should work together. So the total,
Some messages you have given. What about you?
I was saying zero defect concept.
Zero defect. JT program is a different one. You're talking about maintenance.
Yeah, maintenance. I think the 5S concepts
So
are there.
defects are there.
5S is there.
No, 5S is okay, fine. But, call it there. What is the difference between maintenance and total productive maintenance? What do you do? And have you ever noticed that whenever suppose your machine is down, your waiting time is expected to be very high. Yesterday your your laptop was down and you waited almost 48 hours. Suppose this machine is down, okay, or for that matter any machine is down. Usually what we'll find that trying to find out that maintenance group or the person is difficult. And even if you approach them, you call him, he says, sir, I am busy, please wait. This has been the case not only here, there, everywhere, throughout the world. Is it okay? They are always busy, the person, maintenance group, whether mechanical maintenance or electrical maintenance, everywhere this is the case. Now, after say 2 days of waiting, he comes and within few seconds, right, he rectifies your mistake. Getting my point? The similar thing might happen. What they have observed, that almost the waiting time is more. Waiting time, I am waiting for it. I am the machinist, I want it, as far as it's handling the machines. But I don't know anything, or I am not given any authority to maintain it. I am not given any authority. Like even I am not given any authority to inspect the item which I produce. That's my baby. But they say that no, inspector should wait. I will check it. It's like policing. Okay. This has been going on for many reasons. Previously, they were all illiterates and all. That practice has been in place for a long time. Now, he comes and 80% of the cases, he takes few minutes of time and is rectified. Right. So this they have observed. They said, okay, 80% of the time, why you are dependent on that maintenance group? Because after all, developing that knowledge base, it's not that easy. If you have, say, a factory employing some 10,000 people, how many are, the maintenance managers? How many persons? The specialized skill and knowledge you require? Very few in number, maybe 50, not more than that. Is it okay? Even in steel plant you get this data. So they say that okay, they are having specialized knowledge and don't involve them for this routine maintenance or for which the rectification is possible, or even by giving certain training to the workers. So 80% of the maintenance jobs will be done by the workers themselves. This is the basic message. Remaining 10 to 20%, the specialized one, is a major failure. Obviously, this will be the responsibility of the maintenance crew. In the process, what happens? That your system becomes more productive, the waiting time or the downtime will be less, and ultimately the company will be benefited, the plant will be benefited. So come whatever may, whatever you say, that okay, zero defects or these, that, philosophy, ultimately when it is in the operational stage, this should be your norm. This should be your norm. How many such cases you have come across where the workers themselves are fully trained to carry out the routine maintenance? Have you come across such scenarios? How many such cases? Very few. But if you visit, the Japanese plant, this has become their practice. That's why they have the authority to say, yes, then no TPM. We don't have any authority. We say many things. In many forums, what I find, that I'm not finding any distinction between TPM or TQM or J defects or all those. All are same. How can it be in fact? So TPM means this. Whatever you do, whatever, ultimately it must be boiled down to this stage. Then you say, sir, yes, workers are fully trained. Sir, they themselves are working, with their routine maintenance. Is it clear? So this is the essential message of TPM. Yes.
Just a broader sense, these are all same because these are all continual improvements. So if you look into the we're giving different tools, but in terms of philosophy wise,
No, it's not. What I'm telling you, the application wise I'm talking about. If you observe these things, because see, I've been telling you that engineering systems, we engineers must be able to develop certain things which are everyone to see is happening. It's not in my mind. I may think, I may be a philosopher, but I may not be an engineer. So that's why there must be some the evidence that yes, if I observe this sort of phenomenon in my system, yes, TPM is in place, otherwise not. It's not that something in your mind. Yes, definitely, that's a necessary condition, but this is not the sufficient condition. In many time, what we do, we reach up to the necessary condition, but it ceases to be the sufficient condition. Is it okay? Yes, that's what implementation is concerned. Is it okay? Obviously, it's a continuous improvement from say ordinary maintenance to the domain of TPM. It's ordinary maintenance. So now, if you want to change the state from say ordinary maintenance to TPM, what are the the responsibility you must what are the action plan you must take? What are the action plans that you have to develop? But that is basically the certain steps you have to carry out. And obviously it is a continuous improvement philosophy. What is the continuous improvement? Initially it was a 60% downtime. That area you have taken up. And you have concluded that maintenance is mainly responsible for this downtime. There could be other reasons also. Now you have initiated say training programs or some other programs for the workers so that they become also the maintenance crew. It takes time and it takes 2 to 3 years time, and now it is reduced to just 10%. So initially the maintenance cost was 7 to 8% of the total production cost. Now it has come down to hardly 2 to 3% of the total production cost. Is it okay? And what they have found that if you want to reduce this maintenance cost, the TPM would be an effective approach with the data they have proved. So the basic concept in any Japanese basic concept is very, very simple. But implementation, they talk about implementation, nothing else. Okay. So now,
Sir,
Yeah.
could you please explain in a practical example?
this is a practical example.
You mean real,
The real, this is a real one.
grassroots level?
The grassroots level I am talking about.
I can give you
Yeah.
an example.
Yes.
I was in power plant generation and we have.
I'll tell you, I'll give you one example please. I'll give you one example.
So there is an operation department and maintenance department. So there is a regulation gate which you can say controls the flow of water, and if the regulation gate breaks, the wheel breaks, so the operator won't be able to operate that. Then operator was given the tool to take out the screw. Okay, initially what was happening is he has to wait for the maintenance person, raise a work order, call the person, and then maintenance person will come and change the wheel. Now in TPM concept, what is done is the basic tools are given to operator. That in these scenarios, these basic scenarios, they can take out the screw and they can replace the wheel.
Exactly. So simple training
That
program.
means,
Like,
that means it goes to the point that again you are sharing the responsibility. Initially
Yes.
it was assigned to the maintenance. There is a barrier.
Yes.
That is maintenance. This is operation. And always, I will not do this, or it's your responsibility.
No.
So you are sharing.
No,
you know.
actually-
no, it's not like that.
At
It's
the
not
same
like that.
No.
Then it fails.
Yeah.
If suppose it's a bone of contention, or they are just quarreling, then you are not in a state to, you are in a different plane.
So it's see
Very good
here the operator has saved the time, right? It could be the waiting time could
I
have
tell you,
3-4 hours.
we applied, almost 30 years back, when I was working in a factory, like the two areas. One is the pre-treatment plant. Maintenance was a problem. So there were some, the 10 workers, they will be permanently stationed in the pre-treatment plant. So they were, the trained to carry out all this. This is one application. Second application was the press brake, the bending machines. So okay. So again, the waiting time was very large. In fact, the large waiting time. So that's why we have to reduce. So it's better the workers, they volunteer to come forward. So sir, unnecessarily waiting, I know how to change it. But the authority should be given. That means there must be an executive order on that. Normally what happens, that everything we talk about, but they're taking a chance. We don't want to lose our power. There must be an executive order. Otherwise, it's no, the implementation starts with the executive order. You have an executive order. That is called basically the management commitment. That is the first stage in the management commitment. That is the executive order. And you know how difficult it is to get that executive order from your boss. He tells you many things. He pats you at your back. But as far as executive order is concerned, there is a first step in implementation. He doesn't take any risk, or he hold on to his own power. This is our culture, in fact. As I told you, that if you want to believe in TPM or all these concepts, you must believe in one type of leadership. There is a participative leadership. But it remains at command and control, that masculine type. You have to change it from the masculine to the feminine. Getting my point? So the way the father, the leads, and the way the mother leads, is a distinct difference. So today's context, we are looking at the way the mother leads. Getting my point? Because of many reasons. Sustainability and the implementation in two sense of the term. You're getting my point? So these are the issues. So now another important issue Professor Mohanty has pointed out. That is, he has referred to that automated test equipment, ATE, like the fault diagnosis or the fault identification is a serious problem in fact. It's not that easy. Because what is happening today, the equipment, previously it used to be, the based on design is based on one particular discipline. It's based on the mechanical engineering primarily. Today what has happened, that the product has become very, very complex. That means you need to know what? Mechanical engineering, you need to know electrical engineering, you need to know electronics, you need to know the controls, you need to know even the instrumentation. So all in one. And it's very difficult. And plus another problem is, I've told you that it's a miniaturization of design. It's very simple, small parts which only, is very difficult to maintain. And you can't unless you are highly trained. Okay, now I'll tell you another, case that, very difficult. So it's a multidisciplinary team. Now maintenance, a group you form with, with the knowledge in different disciplines, it's very difficult. So in many maintenance groups training programs, there are cases where they used to say, sir, the product has become very complex. So the maintenance engineer or the maintenance person should be trained on electronics, principles of electronics, principles of mechanical engineering, principles of electrical engineering. But they have also studied for several years. They tried to develop, or they tried to initiate such programs with the maintenance crew. But again, they tried to analyze that what is the effectiveness of such program. A lot of theories and all those. They say that the effectiveness is a big zero. Problem. So, if you want to train them on, that you are talking about, that okay, workers will be trained in the maintenance, it has to be on the job training. Of the job training, like say, like this one is the object of training program, it may not have that effectiveness. That has been conclusively proved. So on the job training program, you are taking that responsibility. What kind of organization style you must have? This is the responsibility I'm talking about. Otherwise, it's just a piecemeal approach, and this, okay, in certain cases, you become successful. In majority of the cases, there is no success stories. So you finish it off. Yes.
I just want to share two cases with my knowledge. One was in one of the packaging company. They found that they were trying to use the maximum shift. They found what happens with the scraps and other things around that shift. The next shift comes, and then there was a problem. There's a loss of time and the loss of speed. And even when there is a maintenance to access, that was a problem. So what they did deliberately, they told that it is the duty of the operator to maintain the machine, the general one, which is very low level one. So it was built in the operational process. So that was very good. And another, recently one of the maintenance manager, fortunately he was doing this master's thesis from the industry. I was his supervisor, he was the maintenance manager from Buen Smelter, which is one of the big smelter company of the Rio Tinto is big company. What he did this visible part, that sometimes these tools and other things are there, but to get those things you waste so much of time. And sometimes, you know, so he tried to visibility and the color coding and other things, so which reduce. So these are the two things what I know from my practical experience. I thought that it's better to share that. Some people think, oh, these are very, very low hanging fruit, whether that will be making any difference. But if that is applied properly, involving the stakeholders, then see, they have some ideas. Sometimes they do not know why the fundamental theories. It is the responsibility of you people to apply those theories, make it work, and do that in a systematic way. So what Professor Mohanty and Professor Ray is telling, those things you have to now take it and find that where are the areas where you will apply and how you will apply, and there is no quick solution. So is that making any sense, that how you can approach those things?
See,
Thank you.
What they have found as far as maintenance systems are, like the fault identification. So this is a serious problem. It's not that easy. And the second one is the troubleshooting. Yeah, fault is known, kind of fault. But what could be your troubleshooting? So this has become really problematic, and that's why there should be proper classification of the types of faults. These are the databases to be generated. Given a machine, what are the possible the faults, and how many types of faults can be in the domain of the workers themselves. So this study is very, very important. Absolutely from the scratch we have to start. Yes.
Yeah, I mean, this is another thing. When you tell something, in Queensland Rail, I'll be showing that one. The solar panel operated system for the lubricators were installed. First electrician who tried to connect that one, since nothing was written and the circuit diagram was not there, did a mistake, and that led to the negative and positive blowout of $12,000 worth of things. There are more than 800 similar things. If you think that if that was not addressed immediately, so what was done, there was a setup, and they developed the do's and don'ts and the circuit, and now all these are coming with that and the training, and after that there was a zero mistake. So I mean, this is something which are the very, very simple examples which gives the idea that listen, how it can be possible that the circuit diagram and the do's and don'ts in that control panel, so that nobody will have to think, even a new person can be able to follow and work it well. Thank you.
What are the situations some 30 years back? The situation has improved. Today the workers' quality has substantially improved. It's the basic education. Previously, it was totally unthinkable. They're giving this specialized, this responsibility to the workers. But mostly they were the skilled people. The education level is very poor. So unless you have the education, so such things you cannot take it. So today the situation is much better, definitely. And the kinds of recently we are involved in a kind of activities which is referred to as ITI. ITI, industrial training institutes and all those. So basically, what we used to have at the national level, we have all these institutes, and basically the trained personnel at the shop floor, we are getting them trained, okay, through this system. And there are many modules they are initiating these days, particularly in the production and manufacturing areas, and the maintenance modules. That means, the workers, these are trained in maintenance. This was not there previously. It absolutely means you just join over there, you'll be under someone's tutelage and you'll be trained. It cannot be like this. Is it okay? So this has been attempted, and slowly, definitely, TPA, there's no other alternative but to go for TPA, either in the original form or some other form. Is it okay? Anyway, so what we are trying to talk about, that when you the choice is yours, you purchase one equipment, install it. Is it okay? This is a capital equipment I am talking about. With ATE and without ATE. ATE means automated test equipment. That means it's a kind of software. That means as soon as it fails, that means you will come to know very easily that where the fault lies, why did it fail, these reasons. Is it okay? Which circuitry and what are, and automatically continuously you get the data, the built-in tests, and by looking at the data, an experienced person can say that what is the present condition of the equipment. So such systems are there. But the main problem is that if you try to get one equipment with ATE, that purchase cost could be very, very high. Maybe 5 times more, maybe 10 times more. So this is not affordable for many organizations. Large organization, for certain cases, for the bottleneck operations, they try, but usually it is not preferred. Is it okay? So we are taking a chance. It's okay, it is within the maintenance contract or within the warranty period. Okay, so if it fails, it becomes the responsibility of the original equipment manufacturer. That sort of scenario still we have. In 90-95% of the cases, we have this scenario. Is it okay? Only in certain cases, 2 to 3% of the cases, scenarios may be different. Okay. Now, I have circulated a piece of paper. The 2 pages are there, and this is just an initiation. We are discussing the robustness. Now, with respect to your system, I have mentioned about the equipment or the machine, but you just think of that what extent you can respond to these queries. Right? So it's a kind of brainstorming, like yesterday we did the same thing.